Welcome students. So today we are going to see NCERT textbook questions of chapter 9, which is amines. This is disclaimer. Okay, let's start with first question, which is exercise 9.1. You have to write IUPAC names of the following compounds and classify them into primary, secondary and tertiary amines. Okay, so you have to tell two things: IUPAC names and their classification. So let's begin with the IUPAC nomenclature. First, we will see the set of rules that we follow for writing the name. Step 1 is you have to identify the longest carbon chain in the molecule as the parent chain. That means to name an amine, identify the longest hydrocarbon chain which is attached to the nitrogen atom. So this is step 1. Step 2, you have to name the parent chain. So you have to name this chain as an alkane. Suppose if it contains 2 carbon atoms, it will be ethane. If it contains 3 carbon atoms, it will be propane. Okay, so you have to name this chain in this manner. Now, if we see the next step, in next step of IUPAC nomenclature, you have to add suffix. Okay, so when you add the suffix, you replace the final E of alkane name. Suppose if it is ethane, so we will replace the E of ethane with amine. Okay, so you have to add the suffix amine to form the base name. Next step involves you have to number the chain. Okay, so number the longest carbon chain to determine the correct base name, ensuring the highest priority functional group gets the lowest possible number. And you have to number the chain that the carbon atom bearing NH2 group receives the lowest possible number. Okay, so the carbon atom with this NH2 group gets the lowest number. Using these rules, we can name the given compounds. So we are going to follow these set of rules and we will name the given compounds. Okay, now let's start naming these compounds. So first, if you see, we have CH3 whole twice, CHNH2. So if you look, this is the structure. So to this carbon, a NH2 group is attached. Okay, so this is a longest carbon chain which has 3 carbon atoms. Okay, and we seeing that to second carbon our NH2 group is attached. So I've done the numbering 1, 2, 3. Okay, so now when we see the IUPAC name, it will be propane because it has 3 carbon atoms. And whenever we are naming an amine, we replace the E of propane by amine. Okay, and if you'll see, here is propane 2 amine. So this 2 indicates the position of this NH2 group. So final IUPAC name will be propane 2 amine. And the common name will be isopropyl amine. Now if we see, this is a primary amine because this nitrogen is connected with 2 hydrogen and 1 R group, which can be either alkyl or aryl. In this case, we have an alkyl group. So nitrogen is attached to only 1 alkyl group. So this is a primary amine. Now in this manner only, we will solve rest of the parts of this question. Next, we have this structure. I can write it in this manner. So first, I will see this is my parent chain. I'll do the numbering so that the carbon which is attached to this nitrogen gets the lowest possible number. So 1, 2, 3. Okay, remember, I will not start numbering with this carbon, because if I start numbering with this carbon, then this carbon to which your nitrogen is attached will get third number, which is absolutely wrong. So I will start numbering from this carbon. So the longest carbon chain is of 3 carbon atoms. So the IUPAC name will be propane 1-amine. 1 indicates that NH2 group is attached to first carbon. Okay. And if you see the common name, this will be N-propylamine. N indicates that this is a straight, simple hydrocarbon chain with no branching. Okay, so this N determines a straight chain with no branching. And if you see, this nitrogen is also connected to 2 hydrogen and this alkyl group. So this will also be a primary amine. Now let's see the third part of this question. Now in third part, if we draw the structure, then this is the structure. Now first select the parent chain. So if you'll see, this is my parent chain because this is the longest continuous carbon chain. Okay, so I'll do the numbering 1, 2, 3. So the parent chain is of 3 carbon atoms, so it will be propane. Now let us check the substituents. So this methyl group is directly attached to this nitrogen. Okay, so in this case we will name this methyl as N-methyl propane 2-amine, because to second carbon this NH group is attached. So it will be N-methyl propane amine. And if you look, this carbon is connected to 1 hydrogen and 2 alkyl groups. So it will be a secondary amine. So common name will be methyl isopropylamine. And if you'll see, it is a secondary amine because it is attached to 2 alkyl groups. Now we will see the next part. Coming on towards the fourth part, we will draw the structure of this fourth part. Okay. So first I have selected my longest carbon chain. So this is my longest carbon chain. So I'll do the numbering 1, 2, 3. Now to a second carbon, a CH3 group is attached. And also to a second carbon, a NH2 group is attached. So can you guess the IUPAC name? It will be 2-methyl propane 2-amine. Okay. So if you see in this case, this methyl group is not directly attached to nitrogen. If it is directly attached to nitrogen, we designate it as N. Okay. But since it is attached to the second carbon, it will be 2-methyl propane 2-amine. And the common name will be tertiary butyl amine. Okay, because to the carbon to which your NH2 group is attached is a tertiary carbon, because this carbon is further connected by 3 other carbons. So this will be tertiary butyl amine, and butyl because it has 1, 2, 3, 4, total 4 carbon atoms. Now if we look, this is also a primary amine because it is connected to 2 hydrogen and 1 R group. Now let us move to the next part of this question. We have C6H5NHCH3. So now we have in this case an aryl amine. Okay, so you will see to this nitrogen a methyl group is attached and this ring is also there. So what will be the IUPAC name? It will be N-methyl aniline. Okay, because since this methyl is directly attached to this nitrogen, so it will be N-methyl aniline. Okay. And you will see to this nitrogen 1 methyl group and 1 phenyl group is attached. So common name will be methyl aniline or methyl phenylamine. Okay. And if you look, this is a secondary amine because this nitrogen is connected to 1 methyl group, 1 hydrogen and 1 phenyl group. So it is connected to 1 this CH3 and 1 this group. Okay. So this is a secondary amine. Now we will see the next part of this question. So you have to write, first we will write the structure of this compound. So this is the structure. Okay. So I have taken this as my parent chain. Okay. So I'll do the numbering in such a way that this carbon gets least priority, least number. Okay. So it is 1, 2. Now 1 methyl group and 1 ethyl group is directly attached to this nitrogen. So it will be designated as N-methyl and N-ethyl. Now which will come first? We will follow the alphabetical order. Since E comes first then M, so we will write N-ethyl, N-methyl, ethenamine. Okay, we'll replace E of this ethane by amine. So this is the IUPAC name. And the common name will be diethymethylamine. Okay. Now if you look, this is a tertiary amine because this N group is connected to 3 alkyl groups. So this is a tertiary amine. Now let's move on to the next. Next part, if you'll see, if we draw the structure, so you will see this is the structure. This is meta showing. This is showing that this NH2, this Br group is meta to this NH2 group. Okay, so if you'll see, we do the numbering 1, 2, 3. So it is 3-bromoaniline. Okay, and if you see the common name, it is M-bromoaniline. So this M shows that this group is attached at meta position. Now if we look, this is also a primary carbon, okay, because this nitrogen is connected to 2 hydrogens and only 1 aryl group. Now let's move on to the next question. You have to give one chemical test to distinguish between the following pairs of compounds. Okay, you have given 5th part and you have to give a test so you can distinguish between these pairs. Now let us see the solution. First, if you'll see, we have methylamine and dimethylamine. So if you carefully see, methylamine is a primary amine because here nitrogen is connected to 2 hydrogen and 1 methyl group. Whereas dimethylamine is a secondary amine because nitrogen is connected to 1 hydrogen and 2 methyl groups. So you have to tell a test that distinguish between a primary amine and a secondary amine. Can you guess the test? We are going to use the test carbyl amine test. So carbyl amine test can be used to distinguish between a primary amine and a secondary amine. Now what happens in case of primary amines? Primary amines give positive carbyl amine test. So if you see isocyanides, they are the product of this reaction which are known for being highly toxic and having very foul smell. So this strong odor is actually what makes this test so useful in the lab. Okay, so if you'll see, you can easily detect the presence of primary amine by the smell. So primary amine, they produce a foul smelling isocyanide. Okay, so this primary amines give positive carbyl amine test, whereas secondary amine produce no such smell in carbyl amine test. So that is why they give a negative carbyl amine test. So if we talk about carbyl amine test, so we will see the reaction, it is a reaction of amines with chloroform and ethanolic potassium hydroxide. So if you'll see primary amines, they produce foul smelling isocyanides, or we can call it as carbyl amines. Whereas secondary and tertiary amines do not react. Okay, this happens because they lack the necessary hydrogen atoms on the nitrogen atom which are required to form the unstable isocyanide intermediate. Okay, so this test is specific for primary amine. So if we look at this reaction, if we have a primary amine which is a methylamine, when we reacted with chloroform in presence of alcoholic KOH, we will see we'll get a methyl isocyanide. So this nitrogen which is triple bonded to this carbon, and this is a foul smelling isocyanide. Whereas if you'll see, in case of secondary amine, when you reacted with chloroform in presence of alcoholic KOH, this gives no reaction. Okay. Now let us move to the next part. Next part is between secondary and tertiary amines. So if we have to distinguish between a secondary and a tertiary amine, we can use Heisenberg reagent. Okay. So if you'll see about Heisenberg's reagent, then this is C6H5SO2Cl. Okay. So you will see this is used to distinguish between a secondary and a tertiary amine. So this is also known as benzene sulfonyl chloride. Okay. So benzene sulfonyl chloride is a chemical compound which is used in organic synthesis for introducing sulfonyl groups into the molecules. So you will see secondary amines when they react with Heisenberg's reagent, which is benzene sulfonyl chloride, they form insoluble sulfonamides. Okay, while tertiary amines do not react, so they form insoluble product. And if we talk about this reaction, okay, we'll see this is Heisenberg reagent, which is benzene sulfonyl chloride. When we react with secondary amine, it forms N diethyl benzene sulfonamide. So you will see this forms a insoluble product, because if you'll see here we have no acidic hydrogen which is attached to this nitrogen. So that is why it is insoluble. Okay, and if we talk about tertiary amines do not react with Heisenberg's reagent because they lack a hydrogen which is directly attached to the nitrogen. Okay, if you'll see in case of secondary amines, we have this hydrogen which is attached to this nitrogen, but in tertiary amines we do not have any hydrogen. Okay, so that is what makes them unreactive. So the reason is given, they lack hydrogen which is directly attached to the nitrogen atom. Okay. Now we will see third one, which is ethylamine and aniline. Now if you'll see, both are primary amine. In aniline we have nitrogen which is attached to 2 hydrogen and 1 phenyl ring. And in ethylamine we'll see that a nitrogen is attached to 2 hydrogen and 1 ethyl group. So both are primary amine. So now you have to tell a test that distinguish between primary amines. So if you'll see over here, ethylamine we have 1 ethyl group, and aniline we have 1 aromatic ring which is attached to this nitrogen. So if you'll see, one is alkyl amine and another one is aryl amine. Okay. So this can be distinguished by nitrous acid test. Okay. So if we'll see that nitrous acid test reacts differently with alkyl amines and aryl amines. Okay, now I'll talk about nitrous acid test. So this is the reaction of amine with NaNO2 and HCl. Okay. So if you look at this reaction, ethylamines when react with nitrous acid in presence of NaNO2 plus HCl, it gives ethyl diazonium salt which is unstable. Okay, and it further gives alcohol, N2 gas and HCl. So ethylamine gives alcohol with the evolution of nitrogen gas. So we are having an alcohol and there is evolution of the nitrogen gas. And if we talk about aniline, no nitrogen gas is evolved because the amino group is attached to the benzene ring, which prevents the release of nitrogen. Okay. So if you'll see, when aniline reacts with nitrous acid in presence of NaNO2 and HCl, it gives only benzene diazonium chloride. Okay. And in this case, you will see it is a stable one. And in this case, no N2 gas is being released. Okay. So this is how you can distinguish between an alkyl amine and an aryl amine. Now next we will see aniline and benzyl amine. Now both are primary amine. Okay, aniline is also a primary amine and benzyl amine is also a primary amine. Now if you'll see, we are seeing between aniline and benzyl amine. If you see the difference over here, in aniline, this nitrogen is directly attached to this ring. Whereas in case of benzyl amine, this nitrogen is attached to this carbon which is further connected to this ring. So aniline is an aryl amine, and in benzyl amine, the amine group is connected to a sp3 carbon. So if you'll see, this carbon is a sp3 carbon. So if you'll see, they can be distinguished, aniline which is an aryl amine and benzyl amine, they can be distinguished by nitrous acid test. So aniline, they form a yellow oily nitroso compound, while if we talk about benzyl amine, they produce a clear diazonium salt. Okay. So let's see further. So we are talking about the nitrous acid test. So benzyl amine, you will see they react with oxidizing agent to form benzyl alcohol, releasing nitrogen gas as a byproduct during the oxidation process. So if you'll see, when you react benzyl amine with nitrous acid in presence of NaNO2 and HCl, they give benzyl diazonium salt, which is unstable, and it further gives alcohol, N2 gas, and HCl. Okay, so it decomposes in water to give benzyl alcohol, N2 gas, and HCl. Whereas if we talk about aniline, so the nitrous acid distinguishes by, if you'll see, in case of aniline, there is no evolution of nitrogen gas. So if you look at this reaction, you react aniline with nitrous acid in presence of NaNO2 and HCl, they'll give a phenyl diazonium salt. Okay, so you will see it doesn't give any evolution of the nitrogen gas. Now moving on further, we have aniline and N-methyl aniline. Now aniline is a primary amine, okay, and if I talk about N-methyl aniline, this is a secondary amine, okay, because here nitrogen is connected to one methyl group and one phenyl ring, okay. So this is a secondary amine. So we have to tell a test that distinguish between a primary amine and a secondary amine, okay. So we just now saw we can use carbyl amine test, okay. So if we talk about carbyl amine test, so we will see in this test what happens. There is reaction of amines with chloroform and ethanolic potassium hydroxide. So primary amines give a positive carbyl amine test, whereas secondary and tertiary amines do not give carbyl amines test. Okay, so this is an aniline, which is a primary amine. When you react it with chloroform in presence of NaOH, you will see a phenyl isocyanide, and this is very false smelling. Okay, and if you'll see, we are reacting N-methyl aniline, which is a secondary amine, with chloroform, you will get no reaction. Now let us see the next question, which is exercise question 9.3. You have to account for following. pKb of aniline is more than that of methylamine. Ethylamine is soluble in water, whereas aniline is not. Methylamine in water reacts with ferric chloride to precipitate hydrated ferric oxide, and Gabriel phthalimide synthesis is preferred for synthesizing primary amines. Now let us see one by one. First, pKb of aniline is more than that of methylamine. So if I talk about pKb, then this values shows us a base strength. A larger Kb means a stronger base, while a smaller pKb also means a stronger base. Okay, so this helps us to compare among different bases. So if you'll see larger Kb or smaller pKb, it indicates that a base is a strong base. Now if you see the negative logarithm, then pKb is equal to minus log Kb. So pKb is the negative logarithm of the base dissociation constant, which is Kb. That quantifies the strength of base in a solution. Now if I talk about aniline, you will see in aniline the nitrogen lone pair is less available for donation. Why? Because electrons on the nitrogen, they are delocalized over the benzene ring, which reduces their availability for bonding or reactions. Okay, so if you'll see over here, the lone pair on this nitrogen is delocalized over this benzene ring. Okay, it is you will see this nitrogen lone pair is not localized. So if you'll see this lone pair, it reduces their availability for bonding or the reactions. So we will see the lone pair of aniline, lone pair of nitrogen in aniline is less available to donate. Okay, so therefore we can say aniline is a weaker base. Okay, so if it is a weaker base, that means it will have a higher pKb value. Okay, because smaller pK means a stronger base, and if it is a weaker base, it will have a higher pKb value. Okay, indicating that it dissociates less in water, which makes it a weaker base. Okay, now moving on further, if we talk about methylamine, so this is the structure of methylamine. To this nitrogen, 2 hydrogen and 1 methyl group is attached. So if you will see over here, the plus I effect of the methyl groups, they increases the electron density on this nitrogen atom, which enhances its nucleophilicity as well as its basicity. Okay, so you will see that amines, they are more methylamine, it is more basic than aniline. Okay, because they have a lower pKb value, means they will more readily accept the protons in the solutions. Okay, so if you'll also see the pKb value, we'll see methylamine, the pKb value is 3.34, and aniline, the pKb value is 9.13. So you will see this has a higher pKb value, that means it is a weaker base, and aniline, which has a less pKb value, shows it is a strong base. Okay, now let's move further. Now we will see second part, which is ethylamine is soluble in water, whereas aniline is not. So if I talk about ethylamine, so this forms intermolecular hydrogen bonding with water. So the substance forms hydrogen bonds with water. It affects its solubility and interactions in the aqueous solution. Okay. So if you look over here, this is a ethylamine, which is C2H5NH, okay, which has 2 hydrogens and 1 ethyl group. Now this hydrogen, you will see, is bonded to this oxygen of water. So you will see this dotted lines, which represents the hydrogen bonding. Oxygen is more electronegative, it will have a partial negative charge, and this hydrogen will have a partial positive charge. So this is ethylamine, which is forming hydrogen bond with water. Hence you will see ethylamine forms hydrogen bonds with water, which makes it soluble. Now if we'll talk about aniline. Now can you guess the reason why aniline is not soluble? So aniline is an aromatic amine. So if you see the structure of aniline, this nitrogen has 1 phenyl ring and 2 hydrogens. So you will see that they do not undergo extended hydrogen bonding with water. Okay, so that means the substance do not form long lasting hydrogen bonds with water. Okay, which indicates their limited interaction and their potential, which affects their solubility. Okay, so you will see there is a presence of a large hydrophobic group. Hydrophobic is water repelling. So if you'll see this C6H5, this is a large hydrophobic group. Okay, so this reduces water solubility and increases the molecular interactions with the non-polar surfaces. So if you'll see over here, aniline is therefore insoluble in water. Okay. Now let us see the next part. Methylamine in water reacts with ferric chloride to precipitate hydrate ferric oxide. So if you will see, methylamine is more basic than water because nitrogen is less electronegative than oxygen. So nitrogen can donate its lone pair more easily, which makes it a stronger base compared to oxygen in water. Okay, so this is what it is given. Oxygen is more electronegative than nitrogen. So that means nitrogen can donate its lone pair more readily than oxygen. And if I talk about methylamine, this is more basic than water due to nitrogen's higher electron donating ability and the plus I effect of the methyl group, which makes it react with ferric chloride to get hydrated ferric oxide. So if you'll see this CH3 group, which has plus I effect, this increases the electron density on the nitrogen. So if you'll see in water, methylamine produces hydroxide ions from water. It produces hydroxide ion which by accepting hydrogen ions from water, which makes the solution more basic. So if you'll see at this reaction, methylamine reacts with water. So you'll see this nitrogen over here accepts a proton, which forms methyl ammonium ion. Okay, and you'll also get a hydroxide ion, which is OH minus. So you will see ferric chloride, when dissolved in water, it separates into iron 3 ions, which is Fe3 plus, and chloride ions, which are surrounded by water molecules, which allows the compound to dissolve and conduct electricity. Okay, so you will see this ferric chloride dissociates to give Fe3 plus ion and 3 chloride ions. Okay, so you'll see when OH minus ions meet Fe3 plus ions, they combine to form a solid which is called hydrated ferric oxide, and which settles out of the solution as a precipitate. So if you look at this reaction, you will see irons Fe3 plus, they combine with hydroxide ions to give hydrated ferric oxide. Okay, and the formula is Fe2O3.3H2O. So this represents a solid compound which is made of iron, oxygen and water. Okay. Now, moving on further, next one is Gabriel phthalimide synthesis is preferred for synthesizing primary amines. Okay, so if you'll see, Gabriel phthalimide synthesis is preferred for primary amines as it selectively forms primary amines by reacting phthalamides with alkyl halides, avoiding side reactions. So you will see phthalimide reacts with ethanolic potassium hydroxide. It forms the potassium salt of phthalimide. So this reaction involves deep protonation of phthalimide molecule by strong base, which results in the formation of the negatively charged potassium salt. Okay. Now heating alkyl halide with a stronger base followed by alkaline hydrolysis leads to the formation of the primary amine through a nucleophilic substitution mechanism. So if we look at this reaction, we have a phthalimide when it reacted with KOH. Okay, so you will see we'll get a potassium salt of phthalimide, and when it's further we are heating it with alkyl halide. Okay, we get an alkyl phthalimide. Okay, and in this case you will see here we have an alkyl phthalimide. When we reacted with NaOH, okay, then we will get a primary amine, which is RNH2. Okay. Now if we'll see further, so aromatic amines, they cannot be made by this way. Okay. So if you'll see, aryl halides don't react with phthalimide ions in nucleophilic substitution, which makes this approach ineffective for such compounds. So aryl halides do not undergo nucleophilic substitution with anion, forming phthalimide. Okay, so if you'll see this phthalimide, when it reacts with KOH, you will see this will form this compound which further heated with an alkyl halide, or when it is further treated with ARX, which is an aryl halide, this will not give any reaction. Okay, because they do not undergo nucleophilic substitution with the anion which is formed by the phthalimide. Okay. So thank you students. This was it for today's lecture. I hope this lecture was helpful to you. Thank you.